Okay, there we go. Hello everybody, welcome to another stream. How are we doing? Yeah, so last stream, we tried to, well, we got the reprojection of the depth buffer in. So now when we move, the depth buffer that turns into the occlusion buffer for the next frame doesn't like jump around. It gets some holes in it, though. You see the sort of holes appear as we move. That's something we want to solve separately, but it's not a big deal because it just means that performance doesn't get good, or is not too good, I guess, when we move the camera, but it's okay. The problem that we set out to solve after that is this LOD pop-in. Can you see how the color changes? This is after our work that we did on it. The first LOD is not so bad, but the ones after are good. Yeah. So if you see, we tried to repeat the normal. Let's go down to this one. We tried to make the spheres repeat the normals of the children's spheres, which are there that exist in the higher levels of detail, right? By turning it into spherical coordinates and working out the normal. As you hear this one, it kind of works, right? But it's not, yeah, it's not quite. I think this black bit here is I don't know anymore. Yeah, I'm not sure. But it kind of works. But the issue is that it's not good enough. I'm hoping for an approximation where if we get far away, we shouldn't see this change happening in the LODs, right? But yeah, so I don't think this approach is the one to go with. So that code I wrote last stream where we calculate the normal, we can now just instead return the regular normal, and we're going to try something different. This is what it looks like without the normal. As you can tell, it's a bit too bright when the LED changes. As it gets brighter and brighter, that's because the surface area of the spheres gets bigger and bigger, and therefore more of it is pointing in the direction of the light. So the way I want to try and solve this problem now, I guess they will get brighter. I think I don't mind them getting a bit brighter, we can fix that. The problem is probably just the way it pops in like that. It really grows on it. So maybe I'm thinking, why don't we render both levels of detail and fade the parent LOD cluster out? And that could... It'll make it so it doesn't look like it's I guess it might still grow over it though. But it won't be as... Yeah, it'd be interesting to try it out. It's not too bad. The issue is though that it definitely hurts performance because you're rendering more spheres. So that is the trade-off. Alright, let me get the light on. So, we should be able to do it in the prepare clusters shader. Although we're going to probably have to pass an LOD in as well. So I also forgot. Off stream, there was another suggestion by Russ Musco to he's made a way to do another way to do what we've done here basically, and this will change the normal of the spheres such that it is the normal where the normal of a child's sphere is split into 2 by 2 by 2. But from far away it might be okay. That's the whole idea. So where we do the pair clusters at level of detail, we do this thing where we select the LOD. Togglebit, how's it going? Thank you so much for the raid. Appreciate it. How did the stream go? Thank you. Going late, yeah. After work. Oh, you was going late. It was going too long. Now I am bananas. Yes. Brain is fried, I imagine. Yeah, not doing bad. Just trying to fix some graphical thing here. It's for 13 hours. Oh, never done that long. 6 hours is like is long when you stream. Wow, 13 hours. No worries, you bail. Okay, I understand. Thank you so much, Raid. Right, welcome Raiders. How are we all doing? We're working on a game from scratch, written in C. We've got custom. Well, the game is all written with an engine using Vulkan, and we've got custom shader compiler which compiles C to Spear V, so we can use C as a shader programming language as well. The rendering technique we're trying to pull off is just a bunch of spheres, and each one of these is a volume of 128 cubed. So you've got about 1.6 million spheres for each of these guys, and I'm trying to make them render fast, but while I was doing that, I realized that I got some sort of like pop-in that's happening. This really grows on, and I'm trying to see if I can sort of minimize this, where the LODs are sort of like growing onto it. Maybe I can't, but yeah, they basically get brighter the lower the level of detail, because the surface area is bigger and therefore more of the light smashes onto the sphere. So yeah, there's these things. So we're looking into fixing this today. Yeah, exactly, a load of balls. Yeah, plenty of balls. Geometrically, it's replacing the normal with the vector pointing from a corner of a cube smaller than the sphere. Ah. Right, to the corresponding point on the sphere surface. I see. Ah, I gotcha. Right, fair play. Yeah, I might have to do a hybrid approach. I'm not sure yet. But maybe it's not possible to fix, and maybe we just try and live with it in a nice way. Because if you don't have this LOD thing, you'll get glitches anyway, because the balls will just be too small, and you just get that sort of repeating twisted circle look. It just appears, which is very nice. Any experience with physics and physics engines? I'm diving into physics, and I thought it would be a good idea to make physics engine from scratch to apply to what I learn. I haven't many more experience with it though. Oh, no, I don't have an experience. Although I have a guy at work who I would go to if I need to refer to anything. But I have saying that I have done some stuff. So there's actually no. What I have resources for is networked physics. That's what I have resources for. If you want those, let me know. But yeah, I've done physics, but I don't really have any resources, and plus it's not really my expertise. So apologies, but I'm sure someone else might in the chat, because there's plenty of other people who build engines in the chat and are into that thing. See, I'm hoping when we select the clusters, so what we do is we go down a tree of clusters. Let me just redraw it, I guess. So you got the root node. This has a 4x4x4 set of spheres, right? Potentially. That's the capacity. And it has a 2x2x2 set of children, an octree. This has 8 children nodes, which all have 4x4x4 sets of spheres. So we check to see if this one is big enough on the screen. If it's big enough, we draw it, and we don't bother checking these. That's how we save time. That's how we select levels of detail. But if it is not, sorry, should I say small enough? Yeah, when it's small enough, we'll render it. So we've got like 32 pixels on the screen, we'll render it. But if it's not small enough, we'll go to its children and check if they are small enough. But what we need to do is we need to say, hey, if this one is twice as small, twice as the smallest unit, or the LOD selection thing, right? If its children are basically going to be rendered, then render this one but transparent and fade it out. It's quite easy to do. So I want to try that. Pick a number between 1 and 10,000. Sure, 99. Um, so here's the if statement when we do the selection. We say if it's got spheres and is smaller than the min pixel height, which is 32, or if it's equal to the final cluster, put it in the clusters to render. So what I want to do, what I want to do is say I guess if it has spheres, so can show or should render, something like that. And we probably need like a should render. I'm not sure how I want to word it. So essentially, you're gonna have two booleans here. If one of them is true and one of them is false, then this is horrible. But we can live with horrible for a bit. So if either of them are true, you go into this thing here and render it. Oh yeah, you also want to yeah, I need to put proper names on. But we want to say if, so I guess we'll have like let's just use like a float 32, call it alpha. Already overkill here. We'll give it 1. So we'll just say if should render 0 is not equal to should render 1. Then alpha, wait a minute. Okay, should render fading out. Or maybe Linux audio. Yeah, it's Linux, the audio. If you unplug it and plug it back in, it doesn't like to. Well, maybe it's OBS the way OBS is written up on Linux at least. Oh, this thing is so damn flimsy. I need to probably get proper lighting in it. Alright, look at that. Sweet. So is lower. Can render fading out. Maybe let's call it that. So this one, you need. So if it can fade out, it must also have children. So it must have spheres within that height, and have children. That works. So can render fading out, should render. So if it can render fading out, or if it should render, then we need to have different alpha if it should not render and can render fading out. Then alpha will be equal to some height in pixels divided by that. So how close is that? And it'll be like over 1 at this point. Because this will be bigger than this. And we should just be able to take away 1. Or you could do times 2. No, you haven't times that. Then we'll do a take 1. Alright, so there's some alpha. We've just got to pass it through though, so I've got to change the data structure, which kind of sucks. But it's just, you know, we're trying something out. So we've passed an alpha in there. Not nice and snug anymore, but it's okay. We can fix that. Then cluster instance dot alpha becomes alpha. So, and it pops out on the array. Now we want to be able to say, hey, go and process the children so long as if it should not render and we have children. Okay, so now that means we've got the alpha passed through. Then when we render the spheres and prepare spheres, we have a color. And we explicitly make it red here. But what we can do, there's some alpha here, right? So, I don't know why I made it a float. Bit crazy. But yeah, we can basically take the cluster volume instance and we can OR the alpha on there. Cast it into uint volume or a cluster instance, I think it's called. Cluster instance dot alpha divided by 255. And then we want to move that up towards. I've got macros for these. But anyway. Move that 24. Click that in the top. Alright, let's see how this works. Let's see. No. I tried to shift left on a float. Clearly. And my compiler's not picking up on it. Shoot. So SpearV's like, shifting left on a float. Eager says, thank you so much, sir. Appreciate it. Thank you for the less than 3. How's things going? 14 months, wow. How you been? Yeah, appreciate the support, as always. Alright, so we're getting nothing shown on screen. This is not good. Oh no, it's in a range between 0 and 1, isn't it? There needs to be a multiply by 255. Right. Now, I'm not seeing any fading. Where am I? Enhance. And it's blurry, but I'm expecting to see some worse performance and some stuff being transparent. We can always print it out. Things are going well. Work is a dumpster fire, but aside from that, it's doing well. Man, but yeah, I hope that dumpster fire gets sorted out. Yeah, it's a good way to describe it and stuff. Yeah, pure dumpster fire. Yeah, I do have them weird LOD. These here, isn't it? I wonder if you know what, we could make only the transparent ones show with just an if statement. Um, but yeah, I wonder. I forgot why that is. I think I convinced myself that it should be. Yeah, it's because their parent. It's because their parent doesn't have any spheres or something. Maybe, or maybe these weren't showing. Maybe this is a different bug. Are these ones? I think this is because their parent. No, maybe the parent is rendering. Oh, I have some weird clusters at the wrong LOD near some transitions. Right. I see. So maybe it is. Oh yeah, this is a bug that happens randomly. Like, would be like when I boot up now. It was since my I forgot what change it was since, but if I turn off the occlusion, it's just a broken volume. I don't know what it was since one of our recent changes. This randomly happens. Bit scary. Oh, there. Oh, yeah. So this is since the changes then. So like these are I'm looking for like bigger ones to be rendered, but they should be like transparent. I've got alpha blending working, right? Maybe I've never tried it. Um, so I could just say, hey, if alpha is greater than or equal to 1, then you guys just can't exist. And then we can try about that. So that's nothing. Like, we're not even getting any ones which are... Oh, we must be, right? Maybe I did... let's do some printing. Alright, let's try this out. Right, I've seen a bunch of zeros. Bunch of zeros. So preparing some spheres, preparing clusters. Oh, the height pixels is less than or equal to. Right, what we want to say if it's greater than the pixel height. Yeah, it's probably a better way of saying it. But we also want to probably say it's less than Yeah, less than that and greater than. Yes, yes, and yes. So messy code is the way. Still a bunch of zeros. Height pixels greater than this, unless that times 2, and got children. So this means we can render fading out. So this must be a bit confused. So we're gonna get some printing still, and have a look at the inputs. We'll just put a couple of floats in there. I'm gonna bother annotating everything I plop in there, you know. Height in pixels. So let's see what sort of numbers we get. Too many spheres. Oh. My eyes, what is going on? Why are we seeing a 0? A couple of zeros in it. That seems like invalid. So I'm doing this seems pretty invalid to me. So I think the printing that's coming out is a bit of an error. Like, no way is that correct. Because oh no, the damn integers. That's why. And there's me being like, oh, they're floats. Right. Now we can look at some numbers. Okay, they're integers. I'm thinking they're floating point numbers, obviously, so when I do the division, don't work. So, there we go. It's going to be better now, at least. So you should see some. Here we go. Right, here's our fading out. So the ones that you're seeing are ones which are fading out only. The other ones are opaque, therefore do not render. I want to see only the transparent ones. And because they're transparent, oh yeah, so basically we go through, we ray trace from front to back. So you eventually hit opaque pixels. Basically. So here's the faded guys, but I'm wondering why these at the back are rendering. Because I said, hey, they've all got to have. I guess it could be. Oh no. I said if they have any, maybe they have slightly under 1 alpha or something like this. It would be interesting to see that value. Like, what is the final alpha? Alpha. Right, so they're all 0 to 1. I don't see. Oh, there's one that hits 1. I don't see anything that goes over 1. So it seems like the maths is on point. So if we Now go down to where we have that if statement that destroys everything that has alpha. Let's go ahead and check this as we go past, and it should be the same sort of thing. A bunch of naught to, a bunch of unorm values. So if we run this without the if statement anymore, do we see a better... Right, the performance isn't massively worse. I'm still seeing... Why are the big ones just appearing? Like, they just appear. They're not fading at all. Maybe the maths is a bit wrong. We do see some sort of fading here. Ooh. Interesting. Make this a bit bigger. You do see them fade here. Kind of nice. And then they just disappear again. What? The fade is the wrong way around. They fade out when they should be fading in, or they fade in instead of should be fading out. So what happens is this alpha calculation needs to be inversed. Like that. So we try that out. We should be seeing a better result. That is actually looking a bit better. You still see it grow. I've got to, I've got to have a on-off button so we can actually see it happening. But they appear, and the lightness sort of, I guess, smoothly comes on by the feels of it. But it's still, I don't know. Maybe it's, yeah. Look, as you can tell, if we do the highest, you sort of get some fading. They fade in, and then the other ones just disappear. So maybe the other ones should fade disappear as well. Because that's where the pop in and out is coming from, right? Is that probably? So maybe we also need to do another fade. So how would you do that? So it's the other way around, where if you should render, you need to be saying so I wonder if it would be, because it wouldn't be for every. So it's like if your parent, I guess it could be related to if your parent is something that has spheres. Because if your parent doesn't have spheres and you sort of fade into existence, maybe that's okay. So maybe you need to do something like, well, in this case, or in the should render camp, and maybe the alpha. So maybe things are naturally transparent in a way. And let's just play around with this for a bit. So if we just did height divided by in pixels divided by, so we're saying, hey, how close is it to this min pixel height for the cluster? So the closer to the height, it would be 1. it will be opaque. I still think it needs to be inverted as well. I think that's the logic. Let's give that a go, just see what it looks like. Whoa, that is incredibly wrong. Zoom. It's like AI is generating. Problem is making everything sort of transparent really does tank performance. Because you've got a lot more balls to pass through in the pixel, well, in the ray tracing shader. But yeah, if something feels off, let's invert this. I should have just did the low LOD view like I did before. Right, this is probably fixed. So you're actually not seeing it as much there. At least I feel like it's just got a bit brighter. That does look better. Things are popping away though a bit. Oh, they're sort of fading in. I guess if we do this, you know, actually performance ain't that bad there. Maybe we can get a lot more performance wins, but yeah, we've got to. I think we've got to move the window of how much the alpha is, because right now we just do a really big window on the alpha. Wrap is complete. Oh right, sorry, I've selected the LOD explicitly. What I want to do is move how big the cluster needs to be before we select it. Right, so they're fading out here. Not good. So we don't want this to happen. And this happens when like we want to know here, this is at max LOD. And this, I guess, fixes the debug view as well. And if we're not at the max LOD, then we'll do this. What? Right, let's give that a go. So when I changed this once, changed the LEDs, this was behaving really weirdly, and now it doesn't, because we've got that if statement in there. That's cool. And also she fixed the problem where that we were actually getting here, right? Yeah, you're not seeing, when they're in max LOD, you're not seeing like holes in it. Ignore the flickering, that's to do with the edge of the screen stuff. We're not fussed about that. But yeah, we're still seeing it show over. So why don't I put a boolean in and we can really judge for ourselves properly. So I need to say like show or alpha blend spheres. So we're gonna chuck in a lovely boolean. So we go to our like immediate mode UI thing, which is UI checkbox. I'm gonna chuck another one of these in. So just be like alpha blend spheres. And then we're gonna put another static boolean in by default they're on, because this is the way. And then we're going to throw it into the globals, which is globally accessible to every single shader, which is super nice. So now we can toggle on this lovely thing. So when we toggle it, we should see a difference. No. Oh, sorry, I didn't put if statements in the shader. I just added the data. So what we want to do is say if gfx global this thing, then do this, like alpha selection stuff. Okay, so if we toggle it now, we should see a difference. Oh wait, it's doing the whole, sorry. So these are the spheres which are actually getting alpha blended out. So we're not, wait, this is interesting. Are they things like causing the, I reckon we can play with different like, I guess we can like play with that. I think when we do this alpha transparency thing, we can play around with different, like, do you want like a linear, or is it like a different, like 1D thing? Yeah, so they just slowly become brighter and brighter, which we can fix the brightness, I think, a bit. It's just the smoothness we want. Why are things just disappearing though? I didn't ask for that. Like, those are not. Oh, I'm just not gonna. That's the way of saying it. Those were not a really small alpha, right? Um, yeah, the way we're doing the alpha, it probably never gets close to 0. For this one, maybe. I gotta have a think about that. But yeah, we should really do this thing correctly. We only want to allow fade out, so if we allow for this alpha blend spheres. Otherwise, yeah, it's going to actually render those clusters. So now if we toggle it, right, it's already looking, because we alpha blend the spheres, it's already looking like it's got more of the light on it there. And that's, I guess, because of, right, because, so where's that line coming from? That's the line in which they become fully opaque. Right, so I guess there's something to do with the, there's something to do with the alpha value. It's clearly not. Yeah. So these are the ones which are, you can clearly see they fade on here. So the alpha value, what do we need to do with the alpha value? Which one is it? It's the one. It's the lower level of detail. I think they both have a part to play in it, actually. I think these are both. So the thing that I want to know is, can we, at this point, see something that's sort of 0.1? No, I guess we can. If it is a root. Alright, I guess let's just go over the maths. So let's start with this one. This one is possible when you're not at the max level of detail. Wait. If you're at the max level of detail, we're not going to fade in at all. That's going to show pop in. Yeah, that's just going to show pop in. Right, so they're not fading out. The max ones are not. Maybe that's the problem, because if you see the higher levels of detail, so sorry, this is the highest level of detail. When the lower level of detail comes over, we're seeing it very obviously there, but they're sort of fading in here, and that's when the children disappear. The lowest level of detail completely disappear. So you see it show really far a lot, right? But now you don't really see them growing over as much. With the higher level, with the even lower levels of detail, they fade in and out. But there is some popping problems here. That's weird, right? What is that? Why is it so much that it just pops? That should really. So there's a bit wrong of an alpha value there, but I think the problem with this one is the fact that that if statement. So that fixed a problem where we were on the highest level of detail and we faded. Stuff was fading in, but the parent doesn't exist. Yeah. No, or doesn't have any spheres on it. Something like that. They don't have any lower LOD spheres there. So kind of sucks because we have to go and read more memory, but we can always solve these problems better later. But we have the parent index, so it's all possible. But yeah, basically you say, oh, Boolean parent has lower LOD spheres. So you say node.parent cluster node index dot spheres bit set. Now we don't want to check the exclusive LOD ones because that's explicitly painted in. These ones are when you lower the, and I'm not sure if we'll keep these ones, but you're explicitly painting at that level of detail. Whereas these ones are the lower LOD these ones are the lower level of detail spheres that got made when the volume was generated. Let's try that out. So if the parent has lower LOD spheres, then you fade. Then you don't. If the parent has lower LOD spheres, then am I allowed to fade? But if this is not equal to U32 at max, and these things here. So we saw that problem where we got that is max LOD thing. So for the max level of detail, the thing is I want to maybe do something like I probably want to say like is debug viewing LOD or whatever. So if this is not equal to data LOD count, then which is the max LOD. Okay. So I think this fixes our problem where we're seeing it. Oh no, it doesn't. Right. Oh, we do see them sort of. No, they're not. It's never true anymore. Oh, what did I do? If the parent has lower LOD spheres, then I should be allowed to fade out. So we're not seeing the children fade out anymore. They're just popping in and out. Yeah, they're purely popping in. So this if statement is never true. Double check this 1 second. Let's see if this shows up. Or I've seen it show up. I said and not. Oh, take 1. Whoops. That was the problem. Right. I think we're seeing it now a bit less. Yeah, here's the line. We were seeing that line. That line was a lot worse. We were seeing it grow when we saw it grow over before. It was really bad. We're still seeing it grow over though, but it's nowhere near as bad. It's definitely better with the fading stuff. Right, this gives me hope. Just got to solve the performance if there is any worse. Hey, collector of stuff, how's it going? How's it going? How you been? So we changed this debug LOD thing. We're not seeing any stuff fading in and out. It's fine. That's what I want. So this was a bug that was happening because the highest level of detail is fading. And I thought, when are you allowed to do this? It's going to really mess up if you get too close though. What I get is I'm at the highest level of detail here. Why are these things fading? Is there just too many spheres that are trying to get rendered? Is that the problem? So why is there any type of fading going on there? So we should render so long as, right. Right, okay, so oh no, there is that max LOD thing. Right, I found the problem now. So if the pixel size is bigger, if the pixel size is bigger than this will go greater than 1. So then we've just got a minute. So it ends up when it turns into an integer, it basically overflows the integer, I think. And it'll, yeah, that's the issue. Yeah, right, we fixed it. So the problem there, right, that's better. I'm liking, where's this going? So the problem was basically we passed this alpha into here as a floating point number. And then like here, we multiply by 255 and shift it right by 24. So that number was bigger than 255. And so those bits, which are only 8 bits, right, end up not, well, there's more than 8 bits of information there. So the value is getting reset back down less than, well, 255. Well, yeah, it wraps around to 0, right, and goes around again. I just realized I need to implement bitmaps. That made me wonder, why do we need different font sizes? Could just generate one font with large font size and scale it with bitmaps. Yeah, so you can do that. It's just not as, you don't get the best looking text because and that's what, if your solution, if what you want is something that is easy and you kind of get like text that just looks, just not the best looking text, basically you just want something that just looks okay, you can do that and it's just easier to implement. The problem comes from, what you have is essentially like, and H is the best letter, right? What you have is like curve information, and you've got to try and, I guess there's a bit big of big pixels, right? But you've got to essentially get the right pixels and sort of anti-alias pixels or whatever to represent this curve, and that, you know, um, if you use bitmaps, right, the only time when it looks perfect is when this H, right, is exactly half the size. Because if you use something that's in between this, you're basically, this is pre-rendered. This is a pre-rendered image. You're getting some sort of like interpolation between that, right? And it's not gonna look the best because it's already done at the perfect alpha blending and everything. But it looks okay. It's not horrible. It definitely is just gonna look better. Have you seen Actually no, don't worry. What is this? Yeah. Do you want to see an interesting thought though? What's the guy's name? Font rendering, Sebastian. I forgot his name. This one. Yeah. Um, this is a good watch if you're interested in looking at font rendering. This is like an alternative approach. It's not really any. It's just like an interesting thing to watch. I've wanted to do font rendering in a similar way. He just explored many different techniques basically and tried them all out. Because sign distance fields, I'm already happy with those as a solution. But I've had my own thoughts around doing it just with the Bezier curve data on the GPU. And he goes and does that basically. There's some problems though, because some fonts are not all good. Um, But yeah, it's a fun watch. Highly recommend. Right, so I'm happy where this is going. Definitely would need some code cleanup, but we're trying to get good quality first, and then we can worry about the performance. Well, I'm keeping an eye on the performance. I'm actually impressed where it's at today. We're rendering, like, we're theoretically rendering more spheres because we're rendering the lower LOD for longer. So right now, I guess we can maybe improve that. So there's this problem. We're still seeing the line, but it's not as much. It's definitely improvement. Let me turn this off. Here's the line before. This was real bad. This was giving me nightmares. But now when we alpha blend the LODs, it still sort of happens, but it's not as bad. Still got some more improvements to go. I won't worry about the alpha blending against this. You know what, I'm going to disable this because it's getting in the way of the beauty of this alpha blended ray tracing thing. So that's called debug render MIPS. Turn that off. Nice little custom shader there to do a specific job. Now we're getting too many of these glitches. This is because there's too many spheres. I want to also fix that problem. So there's like a 2. Here we go. That's 2 million spheres. Let's support up to. Let's do an extra million. Maybe we'll double it. 2097125. Right. 4 million. Ought to be good enough. So, whoops. No. What's going on? Right, the upload cursor. 16 or 619. What? This is old code. It shouldn't even be here. This isn't helping my performance either. Yeah, so models, we didn't have models anymore. Model is like an old thing. We got volumes. I kept this here. Maybe I kept this for. I don't even know why I kept this. Oh yeah, this was the Morton. When I did Morton code sorting. Because I was doing the BVH stuff. Yeah. So we used to do all the sorting CP side. Right. These are running? No, they can't be. I think they are running. Okay, so now we shouldn't get any. We should just be allowed to render way more spheres. We're getting some problems where they will clip out when they go near the end of the camera, but that's expected. I haven't fixed that problem yet. Maybe we could fix that now because it is getting a bit. Yeah, sod it. Let's fix it. Fix that problem. There's something to do with probably signed and unsigned, but then again, it's near the X. Towards the right and the top, the left and the bottom don't do it. I wonder if it's something to do with unsigned wrapping around to big value. And it's a red. Thank you, appreciate it. Yeah, I'm happy with the fading in and out approach. It's good. I was dreading the. Yeah, we've still got a bit to go though. This is still visible, but happy with that. Last stream I was like, the normal thing didn't work, but I think we've found our solution. That means that sphere rendering is not dead in the water. How many balls are we drawing? So each one of these is probably about 1.6 million. So what? Times that by 16. So you've got about 16 million plus 8 million, whatever that is. About 24 million spheres that are attempting to be rendered. And then we obviously have low levels of detail. We select those and don't render the children nodes. And also we have occlusion culling. There's a whole ton of optimizations. So we don't actually render all those 24 million. But yeah, I'm hoping to increase it even further. I want to improve the performance first. But then before that, I want to improve the pop-in. There's still with pop-ins. But yeah, let's fix this issue where they go near the end. So the way we can do that is we simply just we find where we did all of these guys, and we just render one, and then we're going to get out those debugging prepare clusters for render. We're going to get all those lovely debug visualizations back in, and with these we should be able to tell which thing is the problem basically. So we enable these. This will be for our cluster. Should be able to see. Here it is. So right, kind of get some alpha blending going on there. Is that right? I don't know. Oh, they're not right into the depth buffer because they're kind of half transparent. Fair play. Things to fix. Why the finer LOD is darker? It doesn't make sense to you. So I think right. Let me go over my thinking and we'll see if that. Yeah. So with my thinking is this whole patch here, the whole of it is like it's mostly pointing in the direction of the light, if you will. But when you use the lower levels of detail, right, you get more black areas show up because you're getting more spheres that have this like this only has normals which fire kind of towards the light, if you will, so it sort of shows up bright, whereas these have normals which fire sort of like to the side more, right? You have that, and as you go down, increase the quality, you just have way more, right? So at least that's my thinking behind it. Does that seem to make sense to you? Crying out loud, what did I do? I opened up another Milton. Yeah, I think that's what I'm going. Does that make sense? Statistically, it should be the same. Right, so if that is true, we should investigate that problem. But yeah, as you can see these pixels, you're getting more of these sort of, like, you're firing a ray through the pixel, and you're getting versus if I do another one where I change the LOD, then I bring up this, take the same region, and then we'll paste it over. I gotta copy it first. Did I copy it? Yeah. Can you see the difference in pixels? So now you've seen the outline of the spheres, right? And then if we paste, yeah, so we undo it, now you've seen the outline of those spheres. Could it be my anti-aliasing code? That's another thing as well, right? I've got anti-aliasing, where if it misses the sphere, it sort of tries to blend the color onto it and keep going. Maybe these black pixels, like, no. The black pixels are the color of the sphere, right? I'm not sure if statistically it is though. I'm not sure. I'm confused. Maybe it is. Maybe it's not. We need to look into that. It could be the alpha blending. I could turn that off. It's darker because different entities are ultimately different scenes. Yeah, I understand that part, right? We're not, but like, what Rosmasco is saying is that he believes that the surface area from the reason that I've been saying, because my logic is because the surface is bigger, therefore more of the normals point in the direction. But then Rosmasco is saying, well, the spheres are made up of smaller spheres which probably point in the same way anyway. But I don't know, I still believe that there's a, I don't know, we gotta play around with it a bit more. Gotta play around. Right, let's fix this other bug. So when we go near the edge of the screen, right, so it must be the cluster. When the cluster reaches the edge of the screen, the cluster gets gobbled. No. The Coke is gone. Yes, it gets gobbled. So can we do any more sort of we could say, hey, only render LOD 1 and therefore render some boxes for me, please, around the cluster. We're gonna have let's find. Oh, here. Damn it! I could have swore we had this made better. This is not. Local space, and then the half dim. All right, so I want to see. Shoot. So I want to see LOD 1. Here we go. So what's my LOD 1 boxes now? So it's not that. Oh wait, let's move to LOD 1. There's no specific corner which has gone to cause that whole one to disappear. Yeah. So what about... Right, so whole spheres are dropping there as well. So I guess it's the logic where we make those... I think I get it. There's an is occluded function. And I think we do some checking. No, we don't. I thought we did. Let this check. We really should do some off-screen checking. So we've got them in assigned coordinates or whatever. Maybe we could say if... What happened here? Yeah, so it does, looking at the performance metrics, it does seem to come into play that. Let me go off the screen. This ain't fixing the bug. It could be, let's disable, yeah, we can disable occlusion testing and see if this... So just let, if either of these are less than 0. So if the top and left are less than 0, or the bottom and left are less than 0, then it's off the screen. Yeah. It's weird, isn't it? I don't know if it's because the oh, top right. Damn it. I don't know if that's because the occlusion testing maybe. Let's disable that. Oh, the occluders there are definitely causing us a problemo. Oh wait. Yeah. I know why. That's because the... Oh ho ho ho. So we put the occluders on. Right, doesn't partly go. Partly goes over the corners though. No. Let's always return true. That just didn't render into the occlusion buffer when you disabled those, so the occlusion system, I guess, was still running. That is occluded. Okay, it's the is occluded function. It's sampling outside the texture and getting 0. That's the problem. This needs to be minned. Right, I think we found the issue. Hey VMT. Sorry, No, no worries. You guys can chat. It's fine. Doesn't it's all right. Like, there's no problem with people having a conversation in the chat. I'm perfectly fine. Because it you help someone out. Like, I'm not against that. It was speaking about memory allocation and virtual memory and heaps, and there was a disagreement about what the word heap or what heaps are and if they're nonsense. Yeah. Um. Yeah. But yeah, how's things going with MD and Hey Midball One? Good to see you both. How you doing? Um. So last stream was very catastrophic. I was like, damn it, my spheres might not be able to get rendered. They'll just pop in. But today we've been doing the alpha blending thing. It's been looking good. Now they slowly fade in and out, the LODs. And we still see a change, but we've got to improve that. We're going to be improving that in just a minute. But I want to fix this culling issue. So we disable this alpha blending thing. You see what the old system was like. Just grows over. It's horrible. Yeah, this is better. So things are going good. But yeah, this is this +1 thing. So we want to minute. So we can probably work out the offset. We can't use that, so there's no improvement in this function. So we want to be able to say offset or whatever. And the offset would be 1. Okay, I want to say offset x. If coordinate dot x plus 1 is less than gfx global screen dims dot x. That's it. Boolean expressions for the win. And then the offset x and y is going to and voila. That should be the problemo. Nailed. No, what have I done? Was that what it was? Exactly, I'm not giving up on them balls. This is too many. Ah, return true. Ah. Yeah, it's too many for me to give up now, you know. Run a set of functions for manipulating trees with a tree being stored in a serialized fashion. Oh yeah, so you just mem copy it out. I learned some Go. Huh? Today. Oh, sometime today or whatever. I was watching this guy from Iceland who's developing a VPN platform and doing some C Go interop stuff. Oh, you learned some Go today, right? I don't know why I didn't pick up Go as Go programming language. Fair play. Some Go. I tried to learn Go once before C, and it was too much for my brain. This was back when I was a JavaScript guy, and lots of things were too bad for my brain. But yeah, I never went back into it. Like type def char value count note. Yeah. Awesome. Sehr gut. I do a heap airlock. What kind of ray trace am I doing? The ray versus sphere kind. So we're just ray tracing its spheres, but they're being binned into screen tiles. So each screen tile gets an array of spheres, which could possibly. Sorry, each tile gets an array of spheres that overlap that screen tile. Yeah. So when you and then we do a full screen pass in a compute shader, and the compute shader sets up an array that goes through a pixel, and it gets the list of spheres which are in that screen tile, and then it checks over them front to back. And we've already pre-sorted front to back as well. Yeah, and then we do like lovely anti-aliasing and stuff as well, which is nice. Oh, yeah, maybe the anti-aliasing wanted to disable the if the spheres get too small, I wanted to disable anti-aliasing. I think I wanted to do that. Right, so something to do with this still. What's wrong? Um, why is it wrong? It's less than you're allowed. Yeah, it's +2 just to sort of see if there's anything. If there's like a weird off by 1. No, it still fails. Maybe it isn't the sampling then. Must be. It is at a certain MIP level. Oh no, because it's at MIP, isn't it? Because I've already downscaled it. Damn it. Right, here's the problem. It needs to be yeah, so we want to actually shift this by the MIP. And then that will be solution. Oh, for crying out loud. Unless it's near the board, there's like a border and it's grabbing a 0 value. But no, we're setting the whole thing to infinity. So if you grab. So I want to say if this is true, what is the value? What's the occlusion depth looking like? Stuff is occluded? What stuff is occluded? Oh shoot. Yeah, of course, stuff is occluded, damn it. So I'm not populating the occlusion buffer anymore. Okay, what's going in there? Yeah, occlusion depth 0. So this is what I was expecting, right? We're indexing out bounds and getting a 0. Um, hmm. So far, I've written functions that return how many nodes does this subtree have in total, right? So is this your syntax tree for your custom language thing? When I did some tests, I was using indices everywhere and trying to pack the nodes into smaller space as possible. When I did my compiler, and I found out that if you just use pointers, as long as they're allocated in a linear block of memory, you can use pointers and it's fine. That's not the bottleneck. So if you have a syntax tree and you linearly allocate your AST nodes, there's no difference using pointers or indices. Yeah, computers just have enough. They're good at grabbing the cache fast enough. So what's great about using pointers is debuggability, and when you write the code in the code base, you don't have to call a function to say get this node pointer. You can just use the pointer. Each node has exactly 2 fields, the value and the count. How many immediate children it has. Alright, so yours, yeah, but how can you have immediate children? Because that surely doesn't work when you have children that have children, right? Does that make sense? Because then you can't you can't have a tree anymore, right? It's just a 2-level tree. I think I tried to solve. I think I tried to do that in a very similar way when I wrote my compiler. I remember this. Oh, it's depth first. You can right a depth first tree. Right. Right. So you keep track of how many children you have immediately after you. But then you get. Uh, I still don't get it. Every node in that sequence is a subtree of that tree. Yeah, I don't get it. It's a bit of my brain. Trees just sometimes fry my brain. Well, they always fry my brain. Put it that way. Trees. Um. So what do we do with the cluster again? Right, it could just be. So maybe the coordinate itself actually goes out of bounds here. Oh, so why don't we say something like, well, if the coordinate is out of bounds itself, oh wait, that was completely wrong. What am I doing? Yeah, so that is true. I want to print out like something completely random. Okay, so we see this, then it means that our cluster is actually outside of the MIP texture and is sampling it anyway. Crying out loud. Yeah, we're seeing it. Okay, so this problem is basically, but why? I want to see how much we're out by, because this could be problems. Did it make, if it's just on the edge, and I don't see an issue. Maybe there is. Man, printing in shaders. Cannot live without this. It is the best. If you haven't got printing in shaders already, highly recommend investing in getting that working in every setup, or in whatever setup you have. It is amazing. Okay, what do we get printed out of the terminal? No, you Wally. Sorry, I didn't shift right my things. So the MIP must be quite high. Let's just put MIP in there as well. I've got any MIPs we have. Yeah, there's a MIPS count. Wait, why did I do that like a melon? Right. Right, so many MIPS are that many MIPS. Alright, let's see the printed information. 2, 3, 3, 3, 8 out of 10 MIPS. Right, should we see, so it seems like it's just on the edge. Which is okay. So it's on the edge. We don't have any information. Wait, there's something wrong with it. Then why are we getting a 2-1? So largest dim, like, let's think about this. So the largest dim, so pick the largest one, and largest dim of the screen bounded box of the cluster. And we're seeing right. There could be a problem here with like, maybe we need to add 1 or take away 1. Not quite. Right, that fixes it if we take away 1. we don't get those issues anymore. Well, I wonder, if I add one, I guess we get it like too often. Yeah, it shows up even more. Right, could be if I only take away one. Yeah, water's good. Gotta keep that brain hydrated, you know? Right. A neighbor told me a trick. You sprinkle like a couple of drops of lemon on the water bowl and it makes it more palatable. What do you mean by that? What is it? What stops it doing this? Huh? I don't understand. Nah. Right. Not a fan of putting lemon or like lime in drinks. It's just not my jam, you know. Not my jam. So we got a cluster of spheres on the screen. There's a screen bounding box, right? We take the largest dim, say that's 24 pixels. We then get the most significant bit. Let's not do 24, let's do 23, because actually 24 is probably alright. Yeah, 24 is probably a good number. 24's got a couple of bits on, isn't it? A couple of bits. Couple of bells. Yeah, a couple of bits. So when we do a most significant bit index, we get 4. Does that make sense? So if I did 4 and then divided it by 2, 2, 2, 2. I should have just, right, let me put 24 back. So if I shift right by 4, we just get 1, right? Whereas if I shift right by 3, yeah, but that's what I wanted it is to be 1 pixel big. I wanted to find the place where it's 1 pixel big. But if I did 32, that would have been 5. And shift right 5, this would be 1. If not, it'd be 2, right? So I do want to keep it like that. But maybe we should say if it's at the edge of the screen, just for say this thing isn't occluded and just render it. Because it's kind of on screen, kind of isn't. I guess that's the fix I want to go with. Right, that's the glitch that randomly happens sometimes. Alright, it's good. Cool, let's get back into the swing of things. So let's re-enable all of the spheres. Let's disable that debug drawing of the outer. Alright, I'll search for that anyway. Okay, so here's all of our spheres. We've got some lovely alpha blending going on now between the LODs. So they're not being as bad, although they could still be. Oh, not sparkling water. I don't reckon it's sparkling water. It's the volcano water. That's what I recommend. Volvic. It's the best water. The volcano water. Was it sparkling water? Volvic's the best water. It's for rendering stuff. We ray trace everything that's 3D for every reason. Yeah, it's the best water by far, Volvic. But I only get it when I go Sainsbury's, because at Sainsbury's they actually sell it at a reasonable price. It tastes so good. I don't. Yeah, it's just amazing. So yeah, I guess the next thing I want to solve is this, the fading out to solve this problem. And then we're going to like whatever Ross Musker was saying, how the sphere size was shouldn't change the brightness. Right, so this one they pop when what why is it popping? When they fade out, it pops. What about and fade in? Wait, what was I saying? I think the ones that yeah, the ones that come in, I think they don't. It's hard to really show. Yeah, let's see. So the here, sort of, one will just gradually go in. That's fine. So I think let's check the smaller LEDs. Yeah, so it's just the ones that disappear. Oh shoot, what's going on? Why? They're fading in. Right, this is weird. Why is this one here? Not that one there. That just this one here. Why is this fading in and then fading out again? Clearly the wrong way around. So as we go further away, the lower level of detail is fading in. Oh yeah, sorry. Then it fades out because there's an even higher level of detail or whatever. That goes right. And then that, okay. So where that's happening is the is alpha here. So that one is the one that says, hey, I have my parent has lower level of detail spheres. So I'm going to do this, calculate how much alpha. But it kind of, yeah. So the reason is because the children, the child spheres will start rendering, wait a minute. As we go, it doesn't quite get to 0. It's the height in pixels. Yeah. So we've got our spheres here. Say if the recommended height is 32. Up here. So the height to render these is when they're 32 or less, right? Your 4x4x4 set of spheres inside this volume. And what whatever. 4x4x4 set of spheres in that volume. Now, when this becomes 16 or less, wait, is that right? Wait, where's my music gone? It's more important. Yes, the level of detail. Before it was the high level of detail, it was fading. As I was going away from the camera, it was fading out. So the pixel size was definitely getting smaller. Yeah, so as it got smaller, that's it. When it reaches 16 pixels, that's it. When it reaches a height of 16 pixels instead, what happens is its parent, which has spheres, is going to instead be the one which enters this loop, and it therefore never goes and traverses the children and tries to render those. Right, put them on the process ring buffer and process those. So this code will never get reached, and therefore the transition, the alpha never reaches 1 properly. So instead what we want is to use a value like we want to use I don't know. We can either offset it so we're purely going to get yeah, maybe we should times this. So from the values between 32 and 16, we want to be smoothing the yeah. We want to We want to find we want the value to be between 0 and 1. Right, so I guess you just use that reverse lerp. Inverse lerp, whatever, right? Would you? Maybe it's overkill. Yeah, I think that's what we want. That's the maths, isn't it? So, where's the start? So the start is negative. Where's the divide by 2 version? Then the end is that version. And the value is height in pixels. And that's basically it. We shouldn't... should we have to clamp it? Do we have to clamp it? Because it will be less. Phone has lower LOD spheres. But it could always be more. Yeah, I think we've got to do a min. At least a min. Alright, let's try that out. Let's just select the right alpha. We shouldn't get any popping. So let's increase the right, that's looking better already, I think. So what we're seeing is when we saw them fade, as we go away from the away from it, we were seeing the ones. Yeah, it's perfect now. So take a look at these guys. As we move away, they're going to fade out properly now. And they're gone. They're no longer popping away. Ooh. Those were popping away a bit. I wonder why that was. They're not fading at all. They're like a low LOD. Yeah, we still got some other ones popping away though. Some other sort of glitches happening. That's cool. That's a good point. Linear RGB space. sRGB. Unpack it. Wait a minute. It's sRGB. Yeah, maybe that's okay though. Let me try it out. No, let me find it. Where is it? It's hard ray tracer. So we get the color out. I didn't. Oh no, it's linear. Yeah. Calculate sphere color. Yeah. Unpack it from sRGB. Right. I'm not doing the lighting in linear space. I'm doing it in, well, lighting. Yeah, it's really amazing. But yeah, I didn't. That could be part of an issue why the lighting. Yeah, I'm not applying the lighting in linear space in sRGB. So let's convert that to linear now. Let's see how different it looks. Yeah, okay, that could be it then. That could be my issue. Alright, let's try that out. Oh, that's not changing brightness anymore. What's going on? You do kind of see it change over though. Let's disable the alpha blend. We put the alpha blender back on. It's definitely much brighter now. Yeah, I'd say we'll anti-aliasing next. Those are way brighter. Yeah, that makes sense now. The normal is round. Yeah, perfectly round there now. Still seeing stuff pop in. I think it's the ones without parent spheres now. They're the ones that are popping in and out. What? These are fading. Why they are fading. Yes, the ones that don't have. No, they have parents. Have spheres. Yeah, stuff is still popping a bit. Yeah, I can say with anti-aliasing, I'm just trying to fix that popping issue. You got red working. Are you going to add green and blue layer? Yeah, I'm like red, like all colors work. I'm just trying to fix. Maybe I should be using more colors. But yeah, I'm just trying to fix other issues right now. Coloring comes later. I'm trying to fix performance and different issues. Oh, the rendering first. But yeah, what's happening with this fading thing? Like, they're fading away. Alright, they're fading away properly. Oh no, I had the explicit LOD selected. Right. So I had that explicit LOD thing. So only some of them are fading? Like what's going on there? Right, so if we're debug viewing a specific level of detail, we don't really want any fading in and out. Is debug viewing a specific LOD? We don't want any of that really. Yeah, I don't want any fading really. So I think that was the. So I had this kind of high and then this one like that. Great. Alright, so let's disable the anti-aliasing then. Take a look at that. Oh, fair play. Yeah, it's hard to tell if it was a joke or yeah, something else. Okay. Disabling anti-aliasing is in the tiled. Ray tracer. If we didn't hit, we calculate how much we missed by. So prepare for the sharp edges. We're not seeing any change really. Oh my days. We are kind of. There is a bit of a change. Turn off the blending. Okay. It's definitely the anti-aliasing then. But why? So what's interesting now is we're doing the alpha blended spheres, so maybe a. All right, let's take some screenshots, and we'll figure out. Figure out some things. Yeah, so you're getting these dark areas here. So maybe we should yeah, we need it on a toggle. Need it on a toggle, that is for sure. It looked like the anti-aliasing adds extra pixels around the perimeter of a sphere. And those are darker. Yeah, but yeah, I guess it adds more of them. Because they do exist here still, right? But yeah, we should definitely inspect that and fix it. Right. So let's follow this around. AA. No. Anti. Let's spell it out. Um. Uh. Okay, so we want to be able to say GFX global anti-aliasing. Alrighty-o. Do another toggle. So we're going to get a nice... This is really taking up a lot of room. What's going on there? UI checkbox. It automatically cuts top. Of 100, so there we go, so another bit higher up. Okay, so I want to get somewhere like, we want to have a view of kind of everything. Somewhere like that should be enough. Oh wow, wow, okay. Good old toggles. So let's do a full screen one, and we'll view that in Cruto and get all the lovely zoom and zoom out stuff, which is super nice. Super nice. From the clipboard. Let's go. Let's turn off the anti-aliasing. Take another screenshot of the exact same rectangle. Oh no. Oh. Well, I need to take 2 screenshots again. Accidentally closed it. I need the exact same pixels. Okay, so if we take another one. Let's paste to a new layer. Okay. Also now it's toggle layer and voila. So here's it without the anti-aliasing. With anti-aliasing. Problem is we're getting the faded in and out stuff. Oh, print screen on Windows. Ooh. Maybe they have replicated it. I don't know. No, they don't. Well, old print screen didn't work there at least. I can look through the settings at some point. Or maybe now. I guess it's a custom. Hey there, thank you so much for the raid. Appreciate it. How's it going, Atheno? Atheno, how's it going? Thank you so much for the raid. Welcome, raiders. How are we doing? Welcome, welcome. So we're currently working on a 2D, sorry, 2D, 3D engine from scratch. We've got this we're rendering a bunch of spheres as our base primitive, ray tracing those, all written with a bunch of compute shaders, and we're using our custom C compiler, which compiles C code into shaders or into SpearV, so we can use it in Vulkan. So yeah, that's what we're working on. We're trying to fix the LOD pop-in problem. We've alpha blended the spheres. Then Ross Musco was saying that the lighting shouldn't be causing pop-in, or as much. The lighting shouldn't change, because we have an anti-aliasing. Yeah, because we have anti-aliasing, and that is seems to be inserting more dark pixels in places. Right, I think I can see from the out. I can maybe I think I understand what's happening in the algorithm. Ah, interesting. But yeah, any questions? Feel free to ask away. Yes, I need to take 2 more screenshots actually. Oh, there's an active window button. I could have used that one. And I want to turn on the anti-aliasing. So it's got no blended spheres. This is the better one. Right, so we'll turn these two off. Right, here we go. So with anti-aliasing on, with anti-aliasing off. How? No, that's not it. Did I? I think I toggled the wrong thing. One day, one day we'll get the right screenshots. That's got anti-aliasing. This one hasn't got anti-aliasing. Right. Anti-aliasing on, anti-aliasing off. On. Yeah, because it looked transparent. Okay. So off, on, off. Wait, on, off. Yeah, so when it's anti-aliasing on, there's a dark pixel. Just came out here. And obviously in other places too. So what about for the spheres that are closer? These are bigger spheres. But we can get a nice soft image. I like soft, but that dark pixel. Wait. I'm confused again. This anti-aliasing off. Yeah, off is brighter. There we go, nice soft image, you know? Yeah, the dark pixels will show up because that's the unlit side of the sphere. They show up. But when the spheres become sub-pixel, then obviously, oh my days. Yeah, I don't know how we should probably turn anti-aliasing off when it gets so far away. How much better that actually is. Yeah, I could actually make an in-game screenshot button, and I can actually get it to open up in Krita. I could also just make it I could also just render them. Go into screenshot mode and just have zoom in and do mouse controls, but then that would mean I have to. Yeah, maybe not. Maybe just taking them screenshots and then maybe open up in Krita is enough. No, it's ball driven rendering, 100%. So 3D volumes get made with spheres. So the art direction is spheres for everything. Yeah. We're trying to make it seem if we can pull off making something look good. So I'm just trying to render a whole bunch of spheres at the moment. So we've got LODs and stuff like that, and we're trying to resolve this LOD pop-in problem, and then get back into performance. Can you make pixels one single color each? Can you make the pixels one single color each? Change the color of the pixel for shadows. I'm not sure you mean by that they're breadlet. Can you make the pixels one single color each? They end up being a single color. But yeah, we do some alpha. We ray march from front to back, and there is some alpha blending that goes on when you do the anti-aliasing. If you miss a sphere by 1 pixel, it will see how much you missed by and take the color from there and blend it in. Maybe that's part. Let me think about that. Yeah, improving the image quality. Well, we're just fixing a visual pop-in problem and getting back to performance. Because this was a blocker. This was getting in the way of me thinking, Can we even do spheres? But yeah, we can do them. Check that out. They're getting lighter, Kappa. So as we move with anti-aliasing on, right? Interesting. So this is anti-aliasing off. The LODs are not changing. Right. So when we have anti-aliasing on, it's very easy to see the LED change. They get brighter. The spheres get brighter. But Rasmusko pointed out that shouldn't be correct. It's not correct. And he's right. We don't really see the change. But I think we're still going to need the blending though, because things will just pop in and out. But we might need less of it, which is great. So I've got to figure out if I want the anti-aliasing now. Because we've got this smooth blending. Maybe it's not a problem because there's just so many sphere, like... Like, it just makes them nice around the edge, basically, when you're up close. Maybe we only put anti-aliasing on for the highest level of detail spheres. Maybe that's the fix. Because, like, does it really make things better if they're, like... Well, no, but those are the highest level of detail, too. But it does make them darker, you see. I can make better anti-aliasing. This is what I like to hear. Yeah, I can actually make a screenshot button really easy because I have readback capabilities in my... I literally just have to write the code that copies the pixels out. Like, it's dead easy. Your spheres are literally... Your small spheres are individually shaded, which I'm not sure is what you should be doing. Why not? Why is individually shading spheres a problem? Are you talking about when they're subpixel? When they're really small? No, the problem's not related with sorting. Sorting's perfect. It's great. The problem is the anti-aliasing is probably quite rudimentary. Rasmusko's probably got some good ideas. Compute a fractional coverage of the edge pixels. Alpha blend rays that hit the spheres too. Right, so... Right, I can quickly... Right, I don't want to stay up too late, but let's quickly re-go over my alpha blending algorithm. So because we're rendering nothing but spheres, we can exploit this fact, and when we ray trace against a sphere, we can do... so there's the ray to the center of the sphere. Here's the ray that's going through the screen. It just about misses. And we check to see at this pixel distance, so at this distance, sorry, we've missed at the distance of, yeah, so we use trigonometry to get, this is the hypotenuse. Is it? I forget. This is opposite, and that is no. This is opposite. I don't know. Maths ain't my thing. But basically, use trigonometry to calculate how big this length is. Yes, hypot, good. And then we basically say like, if we basically work out if this distance that it's missing by is a pixel, is at least a pixel. Wait, yeah, it's less than a pixel. Then we calculate an alpha value based on how much that it's missed. So this would be probably be 0.5. This will be 0.25, right? Because it's missed by 0.25 of a pixel. So take the color of this sphere, and then the color of this pixel is going to be a transparent version of that at 0.25, right? And we accumulate the transparency. So if we miss something else, like another sphere, if we miss another sphere by a pixel, we do the same thing. We accumulate the transparency. And that's how alpha blending works. So it ends up... Why does it end up being darker though? So yeah, is that similar to what you was thinking, Ross Musco, or how's your fractional coverage of the edge pixels? Is that basically what you're saying, or have you got something else? Alpha blend the rays that hit the spheres too. So that's what I'm not doing. Maybe I could say like it's an inset alpha blend instead, where it only works on the inside of the sphere. No. How does that change? How does that change the... How does that change it? Because if it's an inset, it will change the border, the light border. It'll probably just make that border darker because that'll be... recalculating a normal off the... could be an issue. Yeah, but we don't know if we've missed. How far we are away from the edge. We can, yeah, I guess we can use the same algorithm, right? If we're a pixel away from the edge, we could do that still, I think. Maybe it's possible. Because we recompute the normal here, and then we do the lighting again. No, not again, but in a different place. This is the alpha blending, right? This is us doing the hypotenuse squared and getting the depth and figuring out if we're a pixel away. We then calculate a rough normal by recalculating the closest hit point. So we'll be getting this guy, and then we'll be getting the normal for that. So rather than, say, hitting here, and then getting a slightly different normal. So maybe these normals are way worse. Or maybe they're not. So that could be another reason why they're darker as well. You want it symmetrical. What calls for the situation where your LODs change? If they're less than, if the cluster, which is a 4x4x4 set of spheres, is less than this height, the cluster gets selected and then they'll be rendered. So here we're saying if the cluster is 231 pixels on the screen or less, it will render it. So the bigger ones are getting rendered. As we make that smaller, yeah, we've got a glitch here with the. Yeah, ignore that. Yeah, there's no contribution from the edge hits yet. If you make it inset, it'll be brighter with this lighting. Okay, so I might move it to make it inset instead. We can give that a go. That'll be good. Yeah, it's interesting. Holy crap. Did we just make the performance worse? Can I change the... That's made it way noisier. Why has it made it noisier? Is it because it's fighting with OBS and it's made the frame a bit longer? Or there's way more spheres. Well, I can't quite put a finger on it. There's 10 milliseconds, then there's a 8 millisecond one. Whereas it's quite stable around the 8s if we turn it off. No, it still goes up. Where it goes 8 to 10 instead of... Not sure why that is. We do reach... Anyway. Performance is not that much worse with the blended spheres. I thought this custom render was creating a blob mesh in the end. No. What are you talking about? What are they called? Those blobby spheres that sort of merge together? No, it's not anything like that. That's Chorus Musca, probably going to jet soon anyway. But yeah, thank you so much for your help. Appreciate it. Appreciate it, sir. Have a good night, and I'll see you in a future one. Appreciate it. Choose super song. Yeah, lighting is definitely not. It's just very hard coded right now. Lighting is just there's one directional light, and it comes from up there, and that's all we're doing. It's just a simple dot product. But yeah. But this is good progress today. At least we've figured out ways in which that we could, yeah, not get any sort of LOD pop in. So we're gonna next stream, we're gonna figure out, we're gonna basically nail this problem. We're gonna improve the anti-aliasing. We'll hopefully avoid the dark pixels, and we'll see how high we can make this level of detail slider. And before we sort of notice it, I guess maybe 64 is way too much. Yeah, 32 is the one I'm looking for basically, and maybe on low end hardware we'll make it 64. And that's just the visual things they. Yeah, I don't know if we want the fade in. I don't know. If we can get it to work without the fading. Well, you really can't see. Yeah, the AA definitely helps. It really gives it more. Yeah. But yeah, we're just gonna improve this basically, and then we'll get back onto the performance thing. So yeah, let's find someone to raid quickly. Oh, next beyond on Thursday. That's the day of the week. Thursday, 7:30 p.m. GMT +1. Let's figure out who's on. We're also on Sundays as well if you're free Sundays, there's a Sunday stream, which starts a little bit earlier. Yeah, bedtime. I want to go downstairs and exercise a bit, and then eat some food. You know what I mean? And then go to bed. Cause I got work tomorrow, and I'm gonna achieve so much. But I just need to. Yeah, I see Vulkan, but it could secretly be in Rust. Maybe. You know what I mean? And this is clearly a real person. Anyways, give it a rate. But yeah, thank you so much for coming, everyone. I'll see you all in a future one. No. Yes. And yeah, have a good Wednesday and Thursday. I'll see you all very soon. Yeah.